Good day, everyone. It's
It's nice
nice
to
to
have
have
everyone
everyone
here,
here,
and
and I
I believe
believe
others
others
that
that
are
are
yet
yet
to
to join
join
will
will
be
be
joining
joining
us
us
very
very soon.
soon.
In
In
today's
today's
session,
session,
we'll be
we'll be
having
having
our
our
speaker,
speaker
Paul
Paul
Adams,
Adams,
who
who
is
is
the
the
engineering
engineering
manager
manager
at
at
Selar,
Selar,
discussing
discussing
web
web
authentication
authentication
and
and
authorization with
authorization with
us,
us,
web
web
security in
security in
general.
general.
Um,
Um,
so
so
yeah,
yeah,
that's
that's
it.
it.
Paul, can
Paul, can
you
you
get
get
started with
started
us?
with us? Thank you.
Hello.
Hello?
Yes.
Yes?
Yes, you
Yes, you
do.
do.
You can
You
share
can
your
share your
screen with
screen
us.
with us, yeah? Yeah.
Hello,
Hello,
Kileso.
Kileso.
Okay.
Okay.
All right.
All right, okay. Yeah,
Okay.
okay.
Yeah, good
Yeah, good
afternoon,
afternoon,
Paul.
Paul. Nice to have you. Thank you.
Yes, it
Yes,
is
it is
visible.
visible.
Yes, it
Yes,
is.
it is.
It is
It is
okay.
okay like this.
All right.
All right.
Hello.
Hello?
Ben.
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 an organization, you have to like set this restriction that okay, whatever password you'll be using as a user must not be or cannot be simple. So they are like certain that there are certain. The interesting thing about software engineering nowadays is you don't necessarily need to like do a lot of digging. So they are like help you around validating passwords for you to ensure that your user have like very very strong password. So ensure your user have very strong password is important when you're creating your own password based authentication. Ensure that the connection is secure. So you go to some website and then you realize that like the connections are unsecure. So you have like no HTTPS available on that particular, no SSL certificate basically available on that server. So for things like that, they are very very unsecure, and just ensure that wherever you're asking your user to come and input their username and password has to like be secure. Second thing is hash passwords. So don't so funny thing is I've seen like different kind of scenarios where you see that the what they call it the all of these data that collected from all of these data that are collected from like the users are stored in the database, and then you see some instance where like all these data are stored in those exact form. So it is never advisable for you to do that, because imagine if your database gets compromised. Let's say somebody hacks your DB and then gets all your data. It's not cool for the person to be able to see the password of everybody. So as a user, when a user is registering on your platform or on an app that you built, ensure that you like hash the passwords. Don't just store the password into your DB like as if they are strings or they're just like random characters. Ensure you hash them. And then even beyond hashing, there is this conversation of it has to be a one-way hashing. So like you need to hash in such a way that you cannot unhash. Or I don't know what the word what word I can use there, but like you need to hash in such a way that it is not reversible. So in that case, like for instance, for a lot of companies I've worked for, and even for like a lot of projects I've worked on, even when we get user information, we don't know what the password is. So, like, if you register on an app, for instance, even the owner of the platform does not know what the password is, because they are not storing the password. They are storing the hashed version of your password. So, and the thing about hashing is that since even the owner of the platform does not know the password, nobody knows the password, so your password is secure. So you have to be you just have to ensure that like whatever password you are saving in DB has to be like the hashed version, and then ensure that it is not reversible. Don't hash with a salt, because when you hash with a salt, basically you tend to like what's the word? You tend to like make it like available for it to be like reversed, because anybody that lays down on the salt can easily like just reverse whatever you've done. So yeah, hash in one way form. Now, password-based authentication are done in two forms basically. They are either done via cookies or JWT, which is JWT stands for JSON Web Token. So they are done like either via cookies or via JWT. So I would quickly just run through the differences between like password-based authentication via cookies and password-based authentication via JSON Web Token. Now, for every when you're as a software engineer basically they are like you have like you have like two set of apps most of the time when you're creating a project. Is either you're creating the project as a full stack app where you have like your front end and your back end embedded in one. You see this kind of system with frameworks like the Django, Laravel, Adonis. So a lot of frameworks come with this form of architecture where like they are full stack already. Your front end and your back end are all in one place. And then you have like this other kind of architecture where like you have the client side, which is like the front end, separated entirely from like the back end. So the only way they communicate is via APIs. So why am I like bringing out these two differences? Is because like most of the time when you have like this full stack application, when you have like your front end and your back end in one place, they tend to use cookies for authentication basically. Like that's what they do. They use cookies for authentication. So but when you have This apps separated basically. You have like your client side and then you have like the back end. They tend to use like JWT, JSON Web Token. So I'll go a little bit deeper. Now, how does password-based authentication with cookies work? So it's very, very simple. It's like a very, very interesting process. So the client side collects the username and password. Like obviously, like I'm going to be explaining all these things, skipping the whole idea that like all your users are registered already. So now your users are registered. And how does password-based authentication work? Now the cookie like standard or the cookie format works this way. So you have like those fields, the username and the password. The user inputs the username and the password. Those things are sent to the server side of the application. Now the server verifies these details because I mean like those data needs to exist on the database. So the server verifies and says and returns a response like, oh, user does not exist or oh, password is invalid. The only way the server can do that is just because the server is checking those information against what is on the database. Now, if those informations are valid, if they exist and the hash are valid with the hash, like you check the password, you hash the password that is being sent and you check it with what you have on your DB. And if they are valid, the next thing you do is like you create a session ID. Now that session ID, you create it, you save it in the DB. So for some people, they don't use DB because I've worked on applications where they don't use DB to save session, where they use Redis. So you are free to save it wherever you want to save it. But ideally, you save this session ID somewhere. Then now, after saving the session ID, the next thing you do basically is now send that session ID back to the client side. Now, but this time around, when that session ID is coming back to the client side, that session ID now resides on the header of every request the client will be making to the backend. So, like I said, this presentation might be a little bit technical, but I'll try to break it down as much as I can. So I'll go over that quickly again. So now you have like your general username, password field. User types this information. It goes to the server. The server checks the database. It is valid. The server generates a session ID, stores the session ID in a DB, sends the session ID back to the client. Now, for whatever request the client will be doing or will be making, that session ID would reside in the header of like all those requests. So the good thing about this again is that all these things are web standard. They are like all they all happen in your browser basically very fast. They are standards. They are things that are already built on. There are things that are like existing and then they work very fast. So there are things that even a lot of frameworks have literally helped us handle. Where you don't really we're in this era where you don't necessarily need to like worry about all these things while building an application. The only time you start to like maybe worry about them a lot is if you now want to make certain modifications. But aside all of that, like you are very, very good. Yours is just to pick it and plug it into your system and then you are good. So like basically that's what happens with the cookie standard. Now the second standard, which is very, very common, most especially because a lot of applications that exist right now exist as backend and front end, and then they use APIs. Now, before I leave the cookies, and the reason why cookies are referred to as state password-based authentication is because like the cookies are generated and then they are stored in the DB on the server. But like for JWT now, they are referred to as stateless password-based authentication, and then I'll explain why they are stateless. Interesting thing about JWT is that when so the process starts the same way. A user types in their username and their password. Now those passwords are sent to the backend. Those details are sent to the backend. The backend checks the database to validate if they're actually correct. Still the same process. But now the only difference is that the backend does not generate a session ID. Instead, the backend uses certain information to generate a JWT, a JSON web token. Now that JSON web token is now returned as response to the front end. That's where you have tokens that are returned as where you have like bearer tokens that are returned back to the front end for the front end to consume. Now the interesting thing is that in the those tokens are never stored in the backend basically. They are just generated. So the only thing that you have on the backend is like a key, a secret key. So a secret key resides on the backend. When the information from the username and password comes to the backend, the backend verifies that information on the DB, then uses that information with that secret key to generate a token, which is also known as JWT. That token is now sent to the front end. Then the front end, for every request that is being made, the front end also sends that token back. You see some applications where like those tokens are sent back in the header as authorization bearer token basically, and then you see some applications where those tokens are sent in the body. Most of the time when you integrate with like a lot of all these APIs, you see that sometimes they ask you to send the token in the body, while sometimes they ask you to send it in the header. So basically, this is what happens. So it is very common with applications that have like very very separated architecture. So they have the front end, they have the back end. Why? And the reason why they are stateless is because those tokens are not saved. They are not saved on the back end. They are just being generated on the fly. And then when you send them back, they are verified with that same key to see if they are valid and to see what information is inside them. And like I said, the interesting thing about authentication at this point is that you don't need to think a lot about all these things. So you have packages. I know there's a popular package called Passport that handles everything around JWT. And therefore, cookie based and password based authentication, they come on the fly with a lot of frameworks. I know they do with Laravel, but I don't know if they do with other ones. But yeah, all these things now come predefined in all of all these frameworks. So that's everything around password based authentication. That's how it works. That's what happens in the background, and that's how everything operates basically. So the next one is SSO, the single sign on. Now, this is what I was trying to explain the other time. I am a huge fan of this. Like, I mean, like, for like the longest of time, I'm always praying that when I want to use a new platform, I see signing with Google because I don't want to create any password and use. I don't create any account anymore. I just want to go there, sign up with Google, and continue. So now, single sign-on basically is an interesting leap from password based, and single sign-on exists in two forms. There's the SAML, which simply means Security Assertion Markup Language, and then there's the OpenID route. These two routes basically exist for like mainly two different purposes. So the SAML route basically is not something that you would find commonly on the web. They could exist on the web, but it's not something you find commonly. They are enterprise standards. There are things that, for instance, you have your organization, and then your organization has like internal tools that only tools that you can only log into or tools that you can only access within the organization. They can implement this single sign-on route within the enterprise, within the organization. It's like more or less like a insider thing. So it's not something that I think people would. It's not something that I've used. Funnily, it's not something that I've used, and I don't think it's something that is very very common that a lot of people would use. But like the OpenID route is the one that is very common. It is that route that you have all this signing with Google, signing with Microsoft, signing with Apple built on. Like all of them are built on this other route. Now, and the interesting thing about single sign-on is that they under the hood they all use JWT. So like when you see how all these things are implemented, you realize that they use JWT. So let me explain how it works. So now let's say I have a website and I've implemented signing with Google. So when you click on it, automatically you are redirected to Google to log in with your Gmail and your password because that's the only thing you need to log into Google. Now when you log in with your Gmail and password, Google would then like do all the authentication process. You realize that email and password login is password based authentication. So you see that it is very very funny that like from single sign-on, Google will do password-based authentication. Then Google would now send the site owner or the application that you are redirected from would send them the JWT, the JSON Web Token that was generated for you. So with that JSON Web Token, I can now like get any information I need about that user, and then I can now authenticate the user on my own app. So behind the scene under SSO, JWT is being used, and this is how all of them work basically. Like for all of them, because there are even standards to all of all this things. So ideally, it's not something that any of them just decided to do that way. So there are like certain standards to like certain things that are created on the web. So yeah, that's how it works. Now, the next authentication form I'll be talking about is the MFA, which is like the multi-factor authentication. Now, this was created as just an additional layer, like an additional layer to like every pre-existing authentication method I've mentioned earlier. So, and the reason why they just did this is they realized that okay, aside from just authenticating you, verifying your username and your password, there need to be like another thing we can do to like also verify even further. So that's why they did this. So and right now, the four most popular ways all this multi-factor authenticator work is either through push notifications, or through SMS, or through email, or through the authenticator app. Now, and the concept of this multi-factor authenticator is just built around using what you own and what you know. So I will explain how that works. So take for instance, you log in on Gmail on your Gmail account. Your password is correct, your email is correct, but you have multi-factor authenticator enabled. Now, Google can either tell you to check your phone number that they've sent a specific code. That's like a multi-factor authenticator. Google can also tell you to so for Google they can't tell you to check your email because actually that's your email. But for like other platforms, they can tell you to check your email that they've sent a code to your email. They could also use push notification. So I know that sometimes when you try to log in on your Gmail then will tell you to open your Gmail on your phone and tap a particular number or tap a particular set of numbers. So like they also do that. So that's like ideally one of the ways they use push notification. And then there are also other form of push notification I've seen, most especially with a lot of banking apps. So now, why Authenticator? For me, I really like Authenticator. I use the Authenticator app. So there's this. So I know there is Google Authenticator app, and I also know that there's a Microsoft Authenticator app. Now, this Authenticator app, what they do is that for any platform that supports them, you can connect that app to that platform. So when you now try to log in, they tell you to check that app and check like what code is on that app, and then you just have to check the app, see the code there, and input it, and then you are fine. So I use that a lot, and all these methods are very very good. So, but now the only issue with multi-factor authenticator and why a lot of people don't do it, even a lot of what do you call it, a lot of organizations in Nigeria don't do it, is because it is very expensive. So imagine having to do multi-factor authenticator for all of your users. The moment you have like a million users, so in a day, if you have a million users, and let's say probably in a day, 100,000 users log in, you would have to send 100,000 SMS with 100,000 OTPs. So which is like very expensive. And even for emails, because people actually pay for emails. And funny thing, even for push notifications. So a lot of these libraries that are used for push notifications are paid because you have to pay to use them. So they are quite expensive. That's why a lot of people only use them in very, very, very important cases. So they don't really if you are not running an organization that is extremely large with a lot of money in the bank, people tend to run away from it. So I'll give you another tidbit about multi-factor authentication. So do you know that like Twitter reported that they spend approximately $60 million per year on SMS? Imagine. A majority of those SMS being two-factor authenticator. So imagine, and the reason why they are spending this much is literally just because they have a lot of users. So imagine costs like this will only increase because your users will keep on growing. So yeah, so that's like one very interesting thing. One of the interesting thing around multi-factor authenticator that is on the internet that you see on the internet. So yeah, let's go to the next one, which is the passwordless. So now the passwordless is very very rare. You don't find them in a lot of places. In fact, I can't remember the specific place I've seen them before. But they are like very very rare ways of authenticating. How does it work? It's simple. They don't ask for passwords. The only thing they ask for is an email. You type your email. They send you either a magic link or a magic code. They call it magic link or magic code. Now, when you click on the link, they authenticate you. everything is done. For if it is a magic code, when you just input the code, it authenticates you. Everything is done. It is not very common and it is also very expensive. Now, aside, imagine a company that have passwordless authentication. Okay, if you have passwordless authentication, you don't necessarily need MFA because like they are quite similar. But imagine for every login your user wants to do, you have to send them an SMS. You have to send them an SMS or like an email. That's very 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 expensive. So that's why it is not common. One of the things a lot of organizations look at while building applications is how they can build the best application while they spend reasonable amount of money. Nobody wants to spend a lot of money for anything and all of that. Yeah. The last one on my list basically is the web auth. So the web auth is not common at all. I mean, it was even introduced in 2019. I have not worked with web auth before. I've worked with the other ones, but I've not worked with web auth before. But I've used it because, and anybody that uses, if you use an Apple device, you also would have used it before. So web auth basically is when, like, I think as at let's say 2018, 2016, 17, 18, 19, when biometric authentication became very, very possible. Everybody started using it. The next question was, how can we bring biometric authentication to the web? So, and it was only not until 2019 when the standard was created, and now you can do it, and a lot of browsers support it. But prior to 2019, it was impossible to like do this on the web. So, but now there are like libraries, there are even Node.js libraries and a lot of libraries on the internet you can use to facilitate this. But not a lot of people do this because as a user, for me to be able to use the biometric authenticator, my laptop has to have maybe the fingerprint scanner, or it has to have like the face recognition configuration and all of that. So you really cannot see that all your user will have fingerprint. So that's why people don't use it. But I know that one company that has solidly like used it in all their products is Apple, and it's because like almost every, in fact not almost all Apple devices have like this biometric. So for mobile phones, you have the Face ID. For your laptop, you have the fingerprint, and they all exist everywhere now. So I know if you try to visit apple.com and you try to log into your Apple ID on the web, you would if you would, so there are options where you can use like your face ID to like log in. And then even when you go on websites where you have like login with Apple, when you click on it, Apple would either ask you to use your fingerprint or your face ID instead of even asking to type in any password or whatever. And it's very, very nice. So, but it is not common at all. I mean, a lot of a lot of the standardization happened in like 2019. So yeah, that's why you don't find them everywhere. So that is everything on authentication. So there's a very very thin line between authentication and authorization. So, and I mean, the next thing we're talking about will be authorization. And authorization in sense of how what happens after you're authenticated, and then I want to like, yeah, I want to like maybe add something or show something and all of that. So I will just move my slide. Don't worry, after my presentation, I mean, I'm sure there'll be like time allocated for questions, and then we would take questions. Now, authorization. Authorization simply means hiding, showing, giving privilege, authorizing someone to do a particular action. Now, I'll give two instances. There's not a lot of conversation around authorization. So for in-app authorization, you do those authorization if you want to either show or hide features, maybe a button, or you want to give ability to perform an action, or you want to take away ability to like perform an action. So it is all wrapped around: are you authorizing this user to be able to do this? Are you authorizing this user to be able to see this? So people do authorization in different ways. But the most popular concept that is created around authorization is the concept of roles and permission. Roles and permission. So in app, basically, we do this most of the time if we want to show hide or give ability to users to perform certain action, or we want to take away abilities of users to perform certain action. Now, for third party authorization, now when you okay, yeah, I'll give you an instance. So when you go to, I mean, I believe a lot of people will be familiar with Netlify. So I think the most common example I can use is Netlify. So when you go to Netlify and then you you log in with your GitHub. Now, Netlify does not just authenticate you using GitHub. They also ask for permission. And what are these permission? They ask for permission so that they can also fetch your repositories. Because they know at some point they will need your repositories. They will need to be able to display your repositories to you so that you can easily deploy, since Netlify is like a deployment platform. So they authenticate and also ask you for authorization. That okay, authorize them so that they can also have access to your repositories. Now the thing about that is when you now authorize them, so the JSON Web Token that is generated for Netlify, GitHub will now generate a JWT for Netlify. Now that JSON Web Token that is generated would carry the authorization of the ability to be able to fetch your GitHub repository. So at that point in time, now when you are now on Netlify, you can easily see a list of all your repository. And then the reason why you can see it is because the JWT that is in use has been authorized, has been granted the permission to do all these things. It happens with a lot of other platforms. For instance, I'm trying to think of like a very so like for instance when you use tools like let's say Canva, and then you give Canva access to your Google Drive, so that Canva can now directly fetch files from your Google Drive, can delete files, can edit files. All these things are permission. They are set of permissions. They are set of like permissions that you've authorized a particular platform to have. So and there are also standards for this. I mean, there's like a whole lot of standards around authorization, and in fact, most of all these standards are like they get improved year in year out, and that's where you have conversations about odds and how they work in depth and all of that. So, but basically, these are just like fundamentally everything you really need to know how everything behind the scene. I can categorically say that for every single other form of authentication you must have seen, are one way or the other running directly behind all these things. So yeah, and that's all. My Like I said earlier, my presentations are always very very short and precise. So thank you. So I mean, um, at this point, I can welcome your questions, and yeah, we can you can ask any questions you have, probably from the conversation or maybe something you want to ask, maybe outside, still around web authentication and authorization. Yeah.
Okay. All right. Thank you very much, Paul. I think it was a very insightful session. I would like to ask my question. So when you were talking
Yep.
about what's it called? Um, the slide where I think, can you move on to some slides? Okay. Yes. When you talked about hashing passwords and all,
Oh, okay,
in
okay, yeah,
relation to um password reset, as well as
yeah,
forget password.
yeah,
First of all, let's talk about the concept of hashing. So you have your username, you have your password. When you
yes,
create an account, the information gets sent to the backend, and we know
yeah,
that best practices suggest that we do not store the password directly to the database. It is being hashed.
correct,
You also talked
correct,
about using sort keys or something to such that
yeah,
even the organization can't decode or decrypt the
yeah,
password. So in this
yeah.
context, how then does password reset as
That's
well
what it
as
is for.
forget password work?
Okay, so the concept is very interesting. So there are like two different things people mix. You have encryption and you have hashing. Encryption most of the time means like when you encrypt it, you can decrypt it. Now, there are forms of hashing that can be reversed. But ideally, the best thing you should always do is hashed in such a way that it cannot be reversed. Now, but the good thing is, when you hash, you cannot reverse a hash, but you can check a hash. So I will explain better. That's why reset password, forget password, verify password, and all those things can work. So I will explain better. So let's say my password is Paul, Paul. When it goes to the backend, it is hashed into like random characters, and that's what is stored in the backend. Now, if I want to change my password and then they ask for the old password. Now the question is, since what is in the DB is random characters, how do they know that that random characters means Paul since they can't reverse it? So it's very simple. When you now have like the verified password and you ask the user to type his password and you want to verify if that's actually his password, you can pick that string and check it with the hash. So for libraries that support hashing, there are always two functions. There's the hashing function and then there's the checking function. So the check basically what the check takes is it takes two arguments. The first argument is the string, the second argument is the hash. So it checks both of them. So you can check, but you can't reverse. So you don't know what it is. You don't know what it is. But when you pass a string, you can now check. So everything happens basically, and that's why it is possible that even though on the back end we don't know what your password is because what is in the DB is hash, we can check. But don't forget one thing that it is not necessary. I mean, like as a backend engineer or as a software engineer, I don't necessarily need to know your password. If I work in let's say let's say I work in Facebook, I don't need to know your password before I can log into your account. So there's something they call impersonation where you can implement this method where you can impersonate the user. So most organizations, that's what they do. So when you contact support and you say, "Oh, I have an issue with XYZ," for the support person in most organizations to be able to like attend to you properly, they need to like log into your account and see what you are experiencing. So they are logging into your account not with your password. They don't know your password. But there's a whole different conversation around impersonation where they can now impersonate your account. And then it will look like as though they are logged in as you. And then they can simulate whatever issue you have. And then they can now figure out how to sort the issue. So those are like the logics that happens behind the scene.
Okay, all right. I think you did do justice to that. Thank you. Please, if you do have any question for Paul, kindly up miss, you can ask your question or mute your mic and go on.
Thank you very much for the presentation. I'm just wondering two things, right? One, app to app authentication, right? So you built this back end, but you want to verify the app that is connecting to your back end before you verify the user that is trying to sign into that. I don't know if it makes sense.
Tom, again, you
built a back end, right?
Can you use practical examples?
So let's say Twitter.
Hello? Did you get that?
Right.
Okay, yeah, Twitter. All right.
Mm-hmm. Okay. So Twitter used to have multiple clients that can connect to the backend and pull data. I think they kind of scrapped it now, right? So how do you create a trusted app? So you want to be able to trust that this app that is connecting to your backend is approved. I don't know if it makes sense.
Okay. Yeah. So now the what you are explaining entirely is something that is really, 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 really in deep with OAuth. So I'll explain what exactly happens. Yeah, I'll explain what exactly happens. So now Twitter as a platform. Now I'll explain end to end. I think I understand what you're trying to say, but let me know if I am not on the same track. So now you have Twitter as an app now, and me as a business, the name of my product is Paul app. But I want my users to be able to log in with Twitter. Do you get?
Yeah.
Now the first thing I would do is I will go to Twitter and create an app. So like all of these platforms, they have a dev console. They call them developers console. They have developers console behind the scene. So another user would not know that Twitter have like a developer console or Google. Like the owner of Paul app, I will go to Twitter and create an application there. called Poll App. So on Twitter, I will create Poll App. Now it is Poll App that Twitter would now give Poll App an access that, okay, oh, this Poll App that you've created on Twitter now, you can use it to authenticate any Twitter user on your app. I don't know if you get.
Yeah.
So, but like behind the scene, like even when ordinarily, like you don't even need to think too deep. As a backend person, process is very, very, very straight. Me, I am Paul App. I have gone to Twitter. I have created an app there. Those are just DB records. They will give me a unique token, which is fine. Now, when I'm integrating login with Twitter, the SSO for Twitter on Paul App, I will use that app ID that Twitter has given me, which shows that my app is good, is legit. Now, I will use that app ID in implementing the SSO for Twitter on my website. Now, when my users come and they click on login with Twitter on Poll App, what is actually telling Twitter that this user is coming from somewhere authorized is that my app ID that I've gotten from Twitter earlier on. You get to, but all of that are just mere database creates, give him a valid app ID, and then now I can now use it to authenticate. You get, but like behind the scene, when the user now uses SSO, it's JWT.
Okay, makes sense. The second question for me is this, right? So you have where on your back end again,
Okay.
right? That you need authorization. So you need a JWT token to be able to get data. But you now want to be able to expose a component, right, or a view where the users don't have to sign in to get data.
Okay.
Right. So I'll give you an example. So
give me a practical example. Practical examples are easy to address. Yeah.
So let's take payment, for instance, right?
Oh, okay, makes sense.
Ideally, if I want to get say how much I have in my account, that's
your balance.
My balance, right? I need to be logged in to get my balance, right? At the same time, if I have like pending invoices, right, I need to log in to see my invoice.
Yeah.
But now I want to send a link to somebody to pay on my behalf.
Oh, okay.
And I don't have to send my login details to that person.
Of course.
Right. So I just send him a link, and so he's not going to authenticate himself on that link. How do you solve that issue?
Okay. Interestingly, I've worked with a popular payment company in the country, and I've also worked on exactly something like this. So ideally, you don't need to. So first thing I tell people is, you don't necessarily need to like try to think very, very deep.
Okay.
From the surface. So now everything still stands, everything that makes sense still stands, which is you want to get a user balance, you need JWT. You want to get user invoices, you need JWTs. Those ones are solid. Now the first question is, these payment links, how do you want to have them? That's the first question, which is a question that like the product team, the product maybe product designer or product person will tell you. Now, some product person will tell you that we want the payments link to be on a subdomain, on a separate subdomain, right? Some product team will tell you they want it to not be on a separate subdomain, but like the URL should have like a trailing ID. So maybe podtech.com/pay/an ID. Sure you get. Some of them will tell you a subdomain. So like those are like the first things you need to know how they want it. Now, for whatever case they now tell you they want it, that particular that particular link, if it's a subdomain, that particular subdomain, if it is a link, that particular link would not require authentication. Now, the only important part is the person generating the payment link still needs JWT to generate the payment link. That one will still stand because only authenticated users can generate those links. So that particular step will still exist. So authenticated user will generate the payment link, right? Now, but the payment link itself would be that particular link, the route and that like the route handler would be public, would not require authentication. There will be no middleware to check for authentication.
Correct.
So now that particular route now will carry, if it is carrying a trailing ID, all you just need to do is, that ID would be maybe the trailing ID for the trailing ID. That ID would be like the trailing ID for like the payment link that was generated. Do you get? And that would just be what we use to fetch like the payment. I don't know if you get.
Yes, but for you to access that payment, and you need a DWT to go back to your back end to say, okay, give me the details
No, no, no,
from
no.
this.
You don't. So you don't. That's the thing. So let me explain. Let me go very deep. Database wise, I am logged in as a user.
Yeah.
I generate a payment link in your database. Let's say you have 3 columns, or let's say you have 3 columns. First column is the ID for. Let's say you have 4 columns. First column is the ID for that payment link that was generated. Second column is the UUID, a unique identifier that is unique. Third column is the amount. Fourth column is the user ID, the person that generated it, right? Are you with me? Those are the 4. Now, with that UUID, let's say if you now go to porttech.com/pay/ that UUID, you don't need porttech.com/pay/ that UUID to be protected. All you just need to do is that when that route is visited with an ID, check your DB if that ID exists. If it exists, now you already know the user that created it because in the DB you saved user ID. And whatever information you need to fetch about that user, you can fetch it. So you don't even need JWT. And everything is still safe and secure. Because if the UUID is invalid, it means that payment link would not exist. You can throw a 404 page not found. If the UUID exists, is in the DB, fetch the user information and then just display. If it's just the name you want to display, you don't even need JWT to do any of that because your DB already tells you which user created that link.
So I have a small problem, right? Because you're not hitting the DB directly, right? You're hitting it through a backend, and that backend requires that you would have authorization to do the query.
No, so when you visit the route hits the backend. I don't get your backend don't have your access to the DB.
So there's authentication on that
That's like the first thing. That's what I'm trying to explain. The first thing is you don't need authentication for that route. You have to take out authentication. Or you don't need authentication to query the backend, to query DB. For even websites where you display database content on the home page, how do they do it? They don't use JWT. They don't use authorization. They don't use authentication. You don't need JWT or authentication to query the DB. Querying the DB is separate from authentication and authorization. Do you get? They're like they are very, very there are 2 things that you can decide. So it is now your decision. You can decide that, I want that only authorized user can access my DB. You've made that decision. But it is not a very solid decision because other information that you might want to pick from the DB on the public pages like home page, contact us page, about us page that you probably might be storing in the DB. How then will you now access it? Do I need to be logged in before I access about us page? Do you get? So like it's your decision, but ideally you don't. Good practice says don't. I don't see a reason why you should do that. Yeah.
Yeah, but if you then let's say the person has paid, right? And you need to update that.
Yes.
You can't leave it in public domain, right? You need.
So validating payment is now another leg.
No, it's validated. Payment has gone, but so you need to say that this bill has been paid.
Yes.
Right.
Mm-hmm.
Now you have to write. You have to write back to the backend service.
Yes. So now, what you just said now is now another leg. The first thing is we've agreed that like the link is public. You go there, you make payments. Fine. Payment has gone. All these payment services have webhook services. They either have webhook or you can have like a background worker service that validates any new transaction that comes into the system. If you don't want to use webhook, what does webhook stand for? Webhook routes are protected. In fact, they are not protected or like they are crazily protected. They're not just protected like on the surface. That they are protected with like encryption keys and all of even IP whitelisting. Sure you get. So now that your particular webhook now is listening to your payment provider. If you go on Paystack documentation, there's a full documentation on. I'm using Paystack because it's like the easiest. There's a full documentation on webhook. Now payment is done. Tell the user that your payment is successful. If Paystack says is successful, then Paystack will send webhook to your backend service, and your backend service will just do whatever it needs to.
Okay, fantastic. Okay, that makes sense. Thank you very much.
Yeah.
Who else has a question, please? I think someone raised their hand up earlier. Okay. I think I have one question to ask also.
No problem.
Yeah. So I think there's this attack on website cross-site request forgery. Is that really
The,
related to
so this one.
CSRF?
Oh yeah, yeah, yeah. Yes, yes, yes. So now CSRF, which is cross site something, I can't
Request
remember the full meaning. It's an
request
attack.
forgery. Yeah.
So, but the attack happens. So, how will I explain it? Now, a lot of frameworks ideally have looked for a way to combat like this. Now, that attack is very very common on full stack app. Like, if you have a full stack application, it's an attack that you can have. And I'll give you an instance. So let's assume you have a website, a full stack app. Back and front end is one place, and then there's a form. There's a form. The form has certain fields, and it has like an action URL. I can easily, since the form is, I mean, forms are HTML code, right? I can easily like pull it out, put it on my own personal website, and still be sending the data to your website. Do you get?
Yeah.
Because they are forms, ideally. So and it's so it that's basically what like now creates this whole room for like those kind of attacks. So and then the way most frameworks combat it, I can talk more about Laravel. I know that frameworks do, but I can't really see how other frameworks have fought against it. But if you check on Laravel now, there is a particular token that is included in like the whole app. They call it like a CRF token. So that particular token must exist in every request. That's why when you visit, if you try submitting, so if you are using the Laravel framework, I'll speak in line of Laravel framework now because I know how they handle it. Now, if you pull out a form, that kind of form from a website, and you put it on your own website, and then you are exploiting it, maybe submitting bad content or trying to get stupid content into the DB of the application from your own website. If you try it out, you'll be getting the 419, I think it's 429 or 419 error, which is like page expired. So, but what exactly is happening is that the server needs to validate that this request is coming from the server. Like whatever request is going to the backend is actually coming from the same server. So and then the only way they can validate this is by like mapping and comparing like the token, the CSRF token. That okay, oh, what token is included in this request? Automatically it happens. What token is included in this request? And if that request does not have that token, it will never go. So as if it is a post request and a put request, which are practically for what is used for updating or creating, it will never go. Even if it's a delete request, it will never go. It will always bounce back. So one way to do that is, and I mean, people can. So if you know there are, I know there was once upon a time where people, even I too did it, where we write our applications from scratch. We don't use frameworks, we don't use anything. And those kind of times, if you still do that, you can combat this by writing your own like implementation for it. So you could have it as a middleware that exists in between all your post request, your put request, and your delete request. And you can just have like this token based. You can build like a small architecture around it. That's what I'm trying to point out. Where you have like something that generates a particular code and something that validates that particular code. And your middleware will always check for that code, and then you are good. So, but basically, it's just an attack that where like people get to exploit your system outside your system. So they are doing it from wherever they are, and you can't stop them. So yeah, yeah, it happens. I'm sorry I didn't address that. So it happens a lot with the cookie password based authentication. It happens a lot. So it is something that like most framework have under the hood that fixed it. So you don't have to bother too much again because they're like very known attacks. The kind of attacks that people do on systems now are beyond CSRF. So yeah.
Okay. And how is it different from cross-site scripting, XSS?
Oh yeah, yeah. So for cross-site scripting, basically, it is one of the problems that PHP has always had then, but now PHP does not have that problem again because I mean, like I said, their frameworks are now handling it. So now a lot of websites still do it up to today. In fact, when the other guy asked me how you would generate a payment link. Now look at this. You know, I said the payment link would have like the ID of the payment at the end, right?
Yeah.
So it means something from your database exists on the URL. It's a URL parameter. You get. Now it also means that when you want to query the database, you are picking a URL parameter. I don't know if you get, if you are following, right? So now if you pick that URL parameter and you query it against your database, it means you are querying against your database a URL parameter. But imagine I uh, if I put an SQL query here. So it means the URL parameter you are getting is an SQL query that you are running in your database. I don't know if you get.
I get it. I get it.
So yeah, so you have to be careful. But like I said, frameworks have handled this. For instance, Laravel will never allow queries like that pass through the system. Sure you get. But you also need to be careful. You need to be careful that when you are getting a parameter, you are validating. So when you are picking it, you are even validating before you are querying your DB. So you are validating that data even before writing any sort of query, even if you are using a maybe eloquent kind of architecture. So yeah.
All right. Okay. I think I'm done with my questions. Is anyone else with any questions before we conclude this session? Okay. I don't think anyone has a question. Yeah. Thank you very much. Okay. Adipayo Abdurrahman, is your question?
I, I I can't hear you. Did you say something?
Okay, Abdurrahman, your question, please.
Yeah, I can hear you now, but it's a little bit low. About eh? I seriously can. I don't know if I'm dealing with. I can't hear you.
I think he has issues with his
Can you type it on the chat because I can't hear you. If you can type it, I can just talk about it. So it will also be nice to mention that there are a number of like third party companies that can help you handle authentication from the client end to authenticating to validating to single sign on to multi factor authentication, like everything. So an example, which is something I've used before, is Auth0. So Auth0 is quite popular. They are owned by Okta. Okta is like a very very solid security company. So, but like I mean, those third party applications are quite expensive. So that's why people tend to like look for that route. But you can check them out. They are very nice. Their documentations are nice. You can go through and see how they operate too. But every authentication you have out there really circles around everything we've discussed.
Thank you for mentioning that. I used it some times ago, and it's really cool. You can get to like build your whole authentication everything within a day, and so it's very
Yes.
well. It's, as we said, it's also very expensive. I
Yes.
think it
Yes.
costs $249 a year for the application that you use.
Yeah. So those are like the disadvantages you just get from systems like that. They are quite expensive. So yeah.
Okay.
I don't know if Adiba is still typing his message.
Please, can you signify the bar if you are still with your question, or can call it off?
Oh, okay. Oh, okay. So he's asking if it's possible to have a practical session where they can see how this thing work. Uh,
Um,
I mean, I'm in Ibadan currently, so yeah. So I believe, I mean, if it's going to happen, I think I can make it work on my end. But like, I think that is totally dependent on the organizers and not me.
Okay, we'll consider that for some other sessions. I'm kind of doubting if it will be possible for this year because we're already running through the end of this year session already, and we already have other things pulled up already. But I would surely add it to our plans for a practical session on this. Also, I'll please ask you a question.
Yeah, good afternoon.
Yeah, good afternoon.
Can you hear me?
Yeah, loud and clear.
Okay, I'm sorry, I joined late. I just saw the notification quite late, so I think you guys are almost rounding up before I joined. So I am like what Adibayo asked. I think that particular section will be it. I don't know how you guys might want to do it. So I will see how this thing works. And I also want to know because I joined the community and maybe I'm just a new, let's say newcomer. And I don't know if you guys have a WhatsApp platform too.
Yes, we do.
So those are the questions I.
Are you on the GDSC UI community?
Yeah, yes, I joined. There was a link that was sent to me, so I joined to that link. But I don't know where you guys meet physically, or also the, like I said, the WhatsApp platform.
Okay.
So that if there are meetings ongoing, then I'll be able to join to interact too.
All right. So there are two questions. First of all, the physical meeting. Second, the virtual. So for the virtual, since you're on the GDSC UI platform, on the community, I mean on the WhatsApp community, so just check the other list of communities inside it. You'll see the one for the web, so you can request access for the web, and then you'll be added to the web. But for physical meetings, we have that maybe in once in some months or something like that. So, but majority of our meetings are usually virtual.
Okay.
Yeah.
But I didn't get the WhatsApp response, like the one I asked about WhatsApp. Your mic was quite low for me.
Okay, check the community since you're already on the GDSC UI community, but not on the web. So just check the community, and you should see other groups there, so you can request access for the web, and you'll be added.
Okay.
Yeah.
Okay, no problem. Thank you. Thank you.
Yeah. So thank you very much for it's very nice having you. Doing due justice to the session we had today, web authentication and authorization. I believe many of us here on this call would have taken a whole lot of beneficial information regarding this, and yeah. So this session was recorded and would be hosted on YouTube. So the link to it will be sent to the different WhatsApp group GDSC UI. Yeah. Thank you everyone for attending. It's nice having you all.
Thank you, everyone.
Thank you, Paul.
Yeah, thanks. Bye.